Welcome to the online lecture series on 8051 microcontroller. In this video lecture, we shall discuss about the addressing modes. Addressing mode refers to a technique by which the address of the operand is specified. So your operand or the data can be in a register, or it can be in your internal RAM, that is 128 bytes of internal RAM, or it can be in external memory, or it can be a part of an instruction. So addressing mode basically defines the way the data is accessed from any of these locations. Okay, and addressing mode is always defined with respect to the source operand. The first addressing mode is the immediate addressing mode. In case of immediate addressing mode, the operand is a constant and is specified along with the instruction. In 8051 microcontroller, your immediate data should be preceded by a pound sign. This is specific to 8051 microcontroller. Examples are move a hash 25h. Now hash 25h is an immediate data which has been copied to register A. Since we are defining an immediate data, 25h is preceded by the pound sign. So visually also, whenever you see this pound sign, it means it's an immediate data. Similarly, you have 16-bit immediate data being copied to DPTR. One thing you should remember in immediate addressing mode is an immediate data can never be a destination because it doesn't have any address. It's the data itself which is part of an instruction. The second addressing mode is the register addressing mode. As the name specifies, in register addressing mode, the operand is in one of the registers. Okay, and the registers can be R0 to R7. By default, registers of bank 0 are selected. Now in register addressing mode, the source and destination registers should match in size. Examples, move A, R0. Now, as you can see, A is the destination and R0 is the source. So as I have told you earlier, the addressing mode is always defined with respect to the source. So since the source is a register, this is an example of a register addressing mode. Similarly here, accumulator is also a register. That's why this is also an example of an register addressing mode. So basically you see at the source end, and if at the source end a register is mentioned, that is an example of a register addressing mode. The third addressing mode is a direct addressing mode. In direct addressing mode, the address of the operand, that is the RAM location, 128 bytes of the RAM location, is part of the instruction. All 128 bytes of internal RAM may be used as an address. How do you differentiate between immediate data and direct? So that pound sign distinguishes between the immediate and direct addressing mode. As an example, move R0, 40h. Now as you can see, at the source end, the direct address, the direct RAM location 40h has been mentioned, but no hash symbol has been written. Why? Because hash symbol is written only if you want to write an immediate value. So if you want to mention a RAM location, that pound sign is not been written. So that pound sign basically differentiates between an immediate and a direct address. So in this example, the contents of the RAM location 40h are copied to the register RC. So the source is a direct RAM address. That's why this is an example of a direct addressing. Similarly, you have add R5, 30h. The contents of RAM location 30h are added with register R5, and the result is again stored back in register R5. Fine. So that's about the direct addressing mode. Indirect addressing mode also refers to the memory, but in this case the data of the RAM location is accessed using a pointer. This concept is similar to the pointers concept which you have studied in C programming language. Okay, so here you have register which will point to the address of the memory. Okay, so it doesn't give you the data, but it gives you the address of the data. And in 8051, only registers R0 and R1 can be used to hold the address of the operand. Fine. So the only pointers which can be used are R0 and R1. No other registers can be used as pointers to point to the memory. Fine. And when R0 and R1 are used as pointers, how do you access the content? To access the content, you should use the at symbol. As in C programming, you used to use the star symbol. Here we use the at symbol. Okay, let us understand this by an example because this needs an example. Now, what are the steps for register indirect addressing mode? First is we have to initialize the pointer to register R0 or R1. Initialize pointer register R0 or R1 to any of the RAM locations. For example, if you can see move R0 comma hash 30H. It's very important. The hash symbol is very important here. Fine. And also see the comment I have written. I have not written the meaning of the instruction here. I could have written copy an immediate data of 30H to R0, but that doesn't reveal the functionality of the instruction. Okay, now since I am using R0 as a pointer to point to memory location 30H, so my comment should also reflect that functionality. So that's why I have written initialize pointer R0 to RAM location 30H. So this is the first step when you are using register indirect addressing. Second is access the content of RAM location. Now once you have initialized, how do you access? We use this at symbol. For example, so after this initialization, if I say move a comma at the rate of R0, what does it do? It copies a data from RAM location. Okay, in this case, what is the RAM location? It is 30H pointed by R0. Okay, so this is reading from the memory. So whatever address R0 contains, from that address the data is copied and it is stored into accumulator. Then move at the rate of R0 comma A. In this case, copy data to RAM location which is pointed by R0. So this is writing to the memory. Okay. Now this we shall see with an example. Only with an example we will be able to understand this. So org 0h. Suppose I have a memory location 30H. Let me put some data hash 0ff. So I am putting some dummy data in memory location 30H. Okay, and whenever you define immediate data which starts with an alphabet, it should be prefixed by 0. Okay, now I have to copy this data into accumulator using indirect addressing mode. So what is the first step? The first step is to initialize a pointer. Okay, and which are the pointer registers I can use? I can use either R0 or R1. So let me use R0. So move R0 comma, what is the RAM address? The RAM address is 30H. How do I initialize? R0 comma hash 30H. See, the hash symbol is very important here. If you don't mention hash, the contents of 30H will come into R0, which I don't want. I want 30H itself to be copied to R0. That's why they mention hash. And what is the comment? Initialize pointer to RAM location 30H. Fine. Now after this we have to access the data. Okay, suppose if I want to copy the data of this RAM location 30H into accumulator. So I use the at symbol. So move a comma at the rate of, which is the pointer I have used, R0. R0. What does it do? Copy data from RAM location pointed by R0. Okay. So let us understand this. So let's jump here, here. So what will come in accumulator? In accumulator, FFH will come. Okay. So let's compile this. Now first let us see whether FFH has been copied into 30H or not. So I have the memory location 30H here. So as you can see, 30H contains FF here. Okay. So R0 contains 30H. That is, I have initialized the pointer to the RAM location 30H. Now this is very important. When I say move a comma at the rate of R0, what does R0 contain? R0 contains RAM location 30H. And what does RAM location 30H contain? It contains FFH. Okay. So FFH will be copied to accumulator. Why? Because at the rate of symbol is indicates that this is an indirect access. Okay. So when I execute, if you can see, accumulator contains FFH. So the contents of the RAM location pointed by R0 is been copied to accumulator. So this is the way we use the indirect addressing mode, and this is one of the most powerful addressing mode which we will be using in the programs. Okay. Then the next addressing mode is the bit addressing. Now as the name specifies, in this case a bit of a register or a bit address of a RAM location is being accessed. So the data is a bit. Okay, what can be which is the location of RAM address which is bit addressable? The bit addressable area is 16 bytes. It starts from 20H to 2FH. Okay, and the bit addresses are between 00H to 7FH. So for this you have to refer the internal RAM organization of 805, which has been explained in detail. Now clear 04H. So 04H here is a bit address. So what does it say? Clears the bit 4 of RAM location 20H. Then set bit P0.2. Okay. So in this case, the bit 2 of port 0 is being set. So in bit addressing mode, the bit of the RAM location or a register is directly specified along with the instruction. The next instruction is a modification of the bit addressing mode. It is called as bit inherent addressing mode. What happens in this addressing mode? Why it is called as inherent or implicit? So this is also an example of bit addressing mode, but it is bit inherent or implicit. Why? Because if you see, this is clear C. Clear C means clear the carry flag. Set B means set the carry flag. Now in this example, I have not indicated the register name, but it is understood that I am referring to the program status word register or the flag register. How do I come to know? I come to know by one of its bits. So carry flag belongs to the PSW register. So in this case, I'm implicitly modifying the contents of one of the bits of the PSW register. So that addressing mode where the register is not mentioned explicitly, but it is understood implicitly by the bit being specified, that addressing mode is called as the bit inherent addressing mode. Okay. The other examples can be clear overflow flag, clear parity. Okay, so all these are referring to your PSW register. That's the difference between bit addressing mode and bit inherent addressing. See, here I have explicitly mentioned this belongs to port 0. So the register is mentioned, also the bit of that register is also mentioned. But here I have not mentioned the register, but it is understood. The next addressing mode is the index addressing mode, which is used to access the external ROM. So whenever you want to access external ROM, so the addressing mode used is index addressing mode. So what happens in index addressing mode is you will have a base register, to that you add the offset. So in this case, the base register can be your program counter or DPTR, and register A is used as an offset address. Okay, and the effective address is formed by adding the contents of the base address plus the offset address. There are only three examples: movc a comma at the rate of a plus dpt. Okay, so we are accessing the contents of the code memory. How it is accessed? The contents of the dptr are added with the contents of accumulator. So this forms an external ROM address. From that ROM address, the content is copied to the accumulator. Similarly, for these two instructions. So these are the only three instructions which are examples of the index addressing mode. So you have a base and you have an offset. So these contents are added to find the address. From that address, the data is copied to the accumulator. Okay. So three more addressing modes are there. One is relative addressing mode, absolute addressing mode, and long addressing mode. So these addressing modes are related to the branching instructions. Okay. So when I discuss the branching instructions, I will also mention those addressing modes. Fine. So this completes the addressing modes of 8051 microcontroller.